So I should be live. This is my first time doing it though. If you guys could just give me a thumbs up or something in the chat, let me know. All right, cool. Hey, Malone. All right. So just wait a couple minutes and sweet. Thanks, guys. Just give it a couple minutes and see if a couple more people come in. But in the meantime, I'll go over some basics. So in the Holley software, which you guys should be able to see. Yep, there we go. I'm seeing it on the live now. So in the Holley software, you're going to have an input plugged in for trans-slip. That's going to be pretty much 100% important to torque management. But very simply, all you need is the TCM2650 from Powertrain Control Solutions. Zero Gravity Performance sells a kit, comes with the wiring harness, and it comes with instructions on how to hook it up. The instructions are pretty straightforward. But not everything's 100% like set up correctly. There's like some wiring discrepancies that you have to kind of change if you want. Like I wanted some stuff to work on my Holley dash. Like I wanted the speedometer to work. So I like simulated a vehicle speed output from the TCM2650 and sent that out to the Holley dash. So the TCM2650 has a lot of I/O. I think it's got like 8 inputs and outputs you can use. Let me see if I can load up the software. I'm on my non-tuning laptop. So give me 2 seconds. I'll get it and I'll put it on this real quick. It's a really small file. It'll only take me a second. I'll show it to you, all the TCU, the software for that, because that's probably the only thing you guys haven't seen if you already have a Holley. So just load this up real quick. All right, now let me add that to OBS. Let's see. There we go. Let's see. Put TCU. There we go, just below webcam. So, I don't know why it's only giving you this. You should have something a little bit bigger. It doesn't really matter what we load up. All right. This stuff will be all taken care of. Oh, where'd you guys go? Why is this not loading? That's why. There you guys go. Now you should be able to see. Yeah, exactly. Sorry, Mike. I'm just have to switch between tabs to get to that. So yeah, the TCM controller is just a CAN bus. Essentially, it just communicates with the transmission. So inside of the 6L80s and the 6L90s, they have their own TCM. And anyone who's familiar with the transmission knows that. But if you're like used to, say, the 4L60s and 80s, they're just a hydraulic dumb transmission. So whenever you want to shift, you just command hydraulic fluid to go somewhere and it shifts. So this stuff you don't have to worry too much about, like the calibration and tuning, trans setup. None of this you actually like do anything with when you get his software, because this would all be like for analog outputs, like the calibration and tuning and the transmission setup. The only thing you ever really become concerned with is PWM 1, 2, 3, 4, 5, and you can see there's a bunch of digital outputs. So it's like PWM, forget which one it is, it's like 1 and 2 are like the CAN bus output. So that's what's sending out all the CAN bus information. You just never touch anything there. 4 ends up being like 4 generates like a torque signal based on like TPS. It's like alpha N for generating a torque signal. So it's looking at engine speed, so RPM, and it's looking at TPS, and that creates a torque number. It's a fake torque number that it tells the transmission, because the transmission's looking for trans temperature. It's looking for transmission. It's looking for torque speed, or sorry, torque amount, and those are like your two big ones. I'd have to take a look at the maps again in HP tuners, but essentially you still do all the tuning for the transmission through HP tuners. The TCU comes with, or the TCM as they call it, the TCM comes with a OBD2 port, so you can plug in HP tuners, EFI Live, or whatever it is that you use to do tuning, and you can talk to the transmission. Now, I don't know if it was a fluke in my case, but my transmission was already unlocked, but maybe that's because it wasn't connected to an engine as well. So with HP tuners, I spent no credits, and I was able to talk to the transmission, program it, do whatever I needed to do. Now, what you do, other than like the small amount of customization that you'll have to do, or that you might want to do, is I took PWM9, in my case, that's what I used, and the table I used, or that I made, was PWM versus transmission slip. And the reason why I did transmission slip is it has to do with, similarly to an analog transmission, the way how the computer looks at like how the transmission shifts is when you command a next gear, the next gear will change command. So say you could do a 1-2 shift. Commanded gear goes from a 1 to a 2, but you're not necessarily in second gear yet. So you have to wait for the hydraulics to catch up. Well, with the 6L80s and 90s, you also have to wait for filling up the clutch pack. Like there's actually a little bit more of a delay between gear command and the actual end of the gear completion or the start of the transition. But the shift time, the actual time of, hey, I'm engaging these clutch packs or separating clutch packs, can be incredibly fast. I've had my transmission with the shift times as low as 80 milliseconds. I had one as low as 50 milliseconds, and then that broke a shaft. So you don't want to go too fast on shifts. Best is probably around like 220 milliseconds or so. Like anything around like 0.2 seconds is a pretty good place to tune it to. But anyway, so the reason why transmission slip is there is, and I will move this over from OBS to the Holley now. Data log, here we go. So in the data log, we have, and I have to add this in. I'm going to look for translip, and I'll show you how to get translip in. So don't worry, we'll cover that. How that Holley can monitor translip. So here's translip. Oh man, that's an awful color. We're going to pick a different one. Let's see, where are you? It's gone somehow. Translip, there we go. Let's just make it white. A little bit too thick. There we go, that's a little better. And RPM, do the same, make it a little bit thicker. Okay. So you can actually see these white lines, these bumps. Now those bumps are actually commanded gear changes. So in this case, I don't know what speed I was actually going here. I think I was doing, this is probably like a 1-2 and then a 3. This is a 1-2. This would be like a 2-3 shift here. But what is this, boost? I don't care about boost. I want RPM. And that's why it's completely gone. There we go. So that makes a lot more sense now. So as the engine speed comes up, the next gear got commanded at 7,000 RPM, but the actual gear change didn't occur until about 73. This was when I was at the track. So, but you can see from here down to the bottom where translip is 0, that's where the actual RPM drops. The reason why is you're going to have a fixed ratio when commanded gear doesn't equal your current gear. So when you're in first gear and you command second gear, you're going to generate a slip percentage. In this case, it's around, it says 33%, but in most cases I see, oh, this must be a 2-3 then. 33% is my 2-3 percentage. So like 1-2, it usually outputs like 38%. 2-3 is a 33% trans slip, and so on and so forth. Every gear has their own different ratios, and that's important for later. But I believe this was a 2-3 shift. Now, I don't have any signals saying like what gear I'm in or whatever. I don't have those going to the Holley because I would rather have those inputs for other things in the future. So in this case, this looks to be a 2-3, and you can see it comes up, and then only when it starts coming down, that's actually it engaging the gear. So if you measure the time from here to here, that's how long it actually takes you to do your, that's how long it's taking you to actually do your shift. From the time of applying hydraulics to the time it's complete, now you're in the next commanded gear. So what I want to do is, well, a lot of people might say, let's just pull timing based on slip percentage then. Well, that means you're pulling timing that entire time. From this point to here, from commanded time till it actually starts creating a drop in RPM, you're losing horsepower for no reason. You don't want to be pulling timing here. You want to be pulling timing during that ramp. So get to the finer points here. I'm going to check the stuff real quick. Oh, okay, cool. All right. So you can see in these other gears, it's the same thing. Like this, I believe, is my 3-4. It's a 23% change. Now we'll go to Holley. Very nice. We're on the Holley. So the inputs. Simply put, you're going to need to use digital speed frequency. It's a PWM signal that's being sent from the TCM 2600, 2650, 2800, whichever variant you have, they all do the same thing. They all just have like a little bit, there's little bits of nuances between them in terms of their functionality. But like in my case, I have the lowest tier version, the 2600, not even the 2650, and it does the same exact thing. So why the product stacks like that, I don't know. There's my translit. In my case, I'm doing a custom low duty cycle. I believe, so for PWM on that 26, for the 2600, it will only do negative. So it'll only do PWM ground. So that means you need to feed, and this is important for getting translip to work, you need to feed it a signal. Now, I don't remember what size resistor I ended up using. I think Matt used like a 7K ohm, something like that resistor, and that worked good for him when he was doing Arnie's LTD. I don't even remember what I used for mine. I ended up putting a potentiometer on it, and when it started working good, I kind of matched the resistor, but I don't remember what it was. So get yourself one of those like Amazon boxes of like it's like a small electronics box, because they're incredibly useful and they have tons of different resistors in it. So anyway, so you need to provide a positive signal. So I'm providing positive signal for my my ignition switch. So when my ignition's on, it's providing the 12 volts, and then the TCM 2600 is grounding that out, creating the PWM signal. Now, I tried a bunch of different frequencies, and maybe it's because I didn't shield my cable, and it probably is because I didn't shield my cable, but I found that 70 hertz worked great. Anything else, I mean, there's some which are really good, but then there's others where there's so much noise, it's just unusable. You're not going to get anything good out of it. 70 hertz was pretty stable. The way I set that up in the powertrain control module, which I'll go back to that. There we go. You go to, what? I don't need you to update. Get out of here. You go to frequency selection. So in my case, I did PWM9. You got to make sure you punch in, and this software is very rudimentary. If you don't hit enter here and you just X this out, this box just goes back to 15. You have to hit 70 and enter. You see how it pushes it over to the right hand side with the actual frequency that you're putting out. So you have to put 70 hertz there. PWM9 is what I used. You can use any of the PWMs as long as the pamphlet tells you you can use them. But I just use 9 because it's the furthest one away from all the other pins, and that's what I wanted to use. So you put that to your 70%. Let's go back to OBS. And there we go. All right, so that's why you have to have the frequencies match, because it's going to send a PWM based on that frequency, and that PWM percentage is going to correlate to this table down at the bottom for duty percent low. You might have to you're just going to have to figure out like what works for you, but you want it to be consistent. I ended up having to put a little bit of an offset on mine because it was like the 0 was really far off. So like when there was no transmission slip at all, it was reading like -2 or something like that, or -4. So I had to offset it. So you just take the whole table. You take this whole table, you offset you plus or minus numbers until your translip at idle is reading 0, or in gear. With the vehicle in gear not moving, it should be 0. Let's see. So that's how you get translip to the Terminator X, and maybe I'm not describing it perfectly, so if you ever get really confused and you don't know what to do, you can just PM me on Facebook Messenger, and I'll be able to help you out with whatever issue you might be having. Kind of rusty on the 6L90 stuff because I have been using a 4L80 for a bit since I broke my trans. And it's not of any fault of what I'm doing, it's just because it's actually more of an HP tuner issue. I did things I shouldn't have done. Okay. This thing is shift detection. All right. So this, we want to activate this table here. This is shift detection. It's going to be based on fuel flow, translip. The fuel flow doesn't even need to exist. You could make it literally anything that's going to be on all the time. So you want the table to be on all the time. So you're, or at least this axis on all the time. So you don't want to use like, say, battery voltage, right? You don't want to use like battery and be like, oh yeah, no, this table will never work because between, you know, I have all these zeros. I don't know. You just want to make sure you have something that makes it work. So if it's fuel flow, fine. Battery, fine. Make it 0 to 20 volts. That means this axis will always be working. And you're just going to take whatever's in this axis and copy it over anyway. So that means it will always be satisfied. Now for the translip, so I was just telling you earlier about the gears. So like the biggest drop is 1, 2. It's like about a 40% drop, but the way how it calculates it out in translip is different. So you come up with about 38%. So 38% drop, it's going to put you in this box here where these 20s are. And I'll get to the reason why that's important later. And then for second gear, it's about, I'm using these numbers 31 to 34.5. Those seem to work good for me. It usually sits around 33%. And then 22 to 25.5. And this is all part of shift detection. Shift detection has nothing else that goes into it. So we'll go to, let's see, where is it? I think it's gear permissive. Yeah, gear permissive, okay. So gear permissive is what's going to activate my table. So if I have a 2D table, here's my 2D table for torque management. Now this makes it so whenever you pull the timing, you're pulling timing on the actual RPM drop. You're not pulling timing before, you're not pulling it after, you're pulling it only during the drop. So when it's essentially going to ignore that fixed percentage that you see. It's going to ignore that, 38% that's consistent. But if you're in that box at 38% and then you start dropping down, then it will enable this table. So you can see that this is switched enabled with gear permissive. Now go back to gear permissive. Gear permissive is enabled when shift detection is below 19.9 and it will deactivate at 70, hysteresis mode. Add to that RPM above 1600. You can add a bunch of limitations to this, like if you don't want torque management to work, below say 30 miles an hour, you can throw in some anti-stall stuff like RPM, TPS below, or pedal position, say below 10%, whatever. You can put in a bunch of stuff here, but this one has to be there. The shift detection below 19.9 and 70%, and then hysteresis mode. It'll automatically do that, the whole hysteresis. And then linked outputs, you need to have this thing called trans timer or translip timer. There's a very good reason for that. This translip timer is going to enable whenever translip is above 15% and deactivate at 2%. So in other words, And again, hysteresis mode. Translip is going to have to go past, it's going to have to go up to be above 15%, and then that timer is engaged all the way until the point where translip is down to 2%. You can think of 2% as being, you know, the gear's done, like you're shifted into the next gear. And the reason why is when you go to the shift detection, so in case you haven't noticed, translip timer is needed for gear permissive. Gear permissive works with shift detection. Shift detection activates gear permissive. Translip timer is a permissive for gear permissive. So on shift detection, the way how Holley was looking at this before I put translip timer on, was when the next gear was commanded, like when you shifted from, when it did like a 1-2 shift, 1-2 would, you get that 38%, you get that 38% translip immediately. Now the thing is yeah, sure, you're in this box, right? So shift detection shouldn't be, or should be, or gear permissive shouldn't be satisfied. Like the wickets for that shouldn't be satisfied. That you shouldn't be pulling timing. But the way how the Holley looks at it is, well, within one cycle, like one computer cycle, I went from 0% slip to 38% slip. Therefore, I had to have crossed by. I had to have crossed by 19.9 at some point, which means enact the gear permissive, so it'd pull timing immediately. So what the translip timer does is, and if you look at the timer for it, it's 5/1000ths of a second. So it's only active for 5/1000ths of a second, and when it's active, that allows the gear permissive to operate, because this needs, translip timer needs to be enabled as well as these conditions in order to enable gear permissive. So gear permissive is going to operate with PWM below 19.9, and it will turn off when it hits 70. So 70 is, if 70 is my deactivation point, and that's translip, I could have it say stop pulling timing early, or I could have it stop pulling timing later. So I could make this a 2%, 3%, 4%, 5%. You can go nuts with it. These numbers in between don't really matter. This is for flare protection. The 12% slip is for flare protection. But essentially what we want is, we want that yellow dot, and I'll illustrate that. I'm going to go to the data log and just put it in the middle of a shift. So this is my 2-3 shift. You can see this yellow dot is right here on in the 20% range. And as soon as I start pulling, you can probably see it on your screen. I can't see it on mine. You can see how the dot will move its way down, but it's not going to deactivate again. You don't want it to like pull timing on the way down to, say, or we're starting here. Say we pull timing through here, and then, oh, hold on, I come back up. You got to remember, as we're going from 0 to 20, we're going to hit 19.9 again. So you couldn't use this in like a range mode where you're looking for, like, say, 19.9 and 20. And these are just activation wickets. You can make these almost any number you want, as long as this number, all these 20s, are lower than the deactivation number, which is 70. Let's see. So when gear permissive is enabled, you can see it. So I'm going to put this like mid-shift. So midway through the shift, you can see we're starting to pull timing. Start at the top. So we're actually not pulling any timing. Now we're starting to. And you can see as we get closer and closer to 0% slip, we end up reducing the amount of timing that we're pulling. So that's our method of torque management. We're knocking a ton of power out of the engine as soon as those clutch packs start to enable. And that allows RPM to drop really fast, remove some load off the transmission, help protect the clutch packs. You get a smoother shift. My 1-2 shifts, like without torque management, were like they created a lot of driveline shock, especially when I started upping or reducing the shift speeds. So, and then for this table, I've made mine load-based and trans-slip-based. Trans-slip has to, in my opinion, it has to be there, and then fuel flow. I mean, it makes the most sense to me to use fuel flow because that's load on the engine. So the more load, the more you might want to knock out of it. Now, let's see if there's anything I've really missed. I'm sorry if this is like a quick rundown because I'd rather get to your questions about it and clear up anything that you guys might not know and maybe explain things in a better way. So this is kind of the rough draft of how it works. Okay. So yeah, again, gear permissive. It's only going to work when shift detection drops below 19.9%, and it will deactivate at 70%. Gear permissive is what pulls timing, not shift detection. Shift detection is the permission for gear permissive. I could have named these all way better, but gear permissive is the way that timing is removed. And then trans-slip timer, you need that. That's a must-have. I put an activation delay on this, but there's really no reason to. It's only 0.002 of a second anyway. So let me get to you guys. Let's see what's going on. There's no PWM that's inputting to the TCM2600. The TCM2600 is outputting to the Holley. The Holley's reading it as an input. And yeah, the trans-slip timer, that's like you need to have it. The Holley it sucks because it wastes an output, but you need it because the Holley it doesn't care. Like it doesn't care that even if you put an activation delay on the gear permissive table, let me make sure I got that right. Yeah, if I were to say omit trans-slip timer and I put like an activation delay on this, that it was big, even if it was bigger, it wouldn't matter. The thing is that the fact that it saw shift detection go from say 70 and at some point it crossed 19.9 or dropped below 19.9, and that would be if I were to go to shift detection. So that would be, here we are sitting fat, dumb, and happy. And then when the gear goes to change, essentially this dot is going to move up to whatever gear it is. So 1, 2, 2, 3, 3, 4. Okay. So as soon as it crosses 12% slip, it drops below 19.9. Now, that's the first time it's going to go through there. The Holley knows that it had to have crossed through this in order to get to up here, wherever it is that you're in, whatever window you're in. It knows it had to cross through there. Therefore, you're going to have to have some sort of a delay which allows this dot to travel up and ignore everything. But if you set an activation delay, it doesn't care. It still sees, okay, I'll activate my table later, but it's not a permissive. It's still going to activate because it knows it crossed through 0. You're just delaying the inevitable. That's all it is. But with the trans-slip timer, because it's permissively set with this, it waits until the translip timer has to be in that box. You know, it has to meet its conditions of above 15% and deactivate. It has to be above 15% for that amount of time before it will enable. And the reason why is because this will stay active when this is active for, or when this becomes active after 5 thousandths of a second. It will activate the gear permissive, which is here. But the thing is that this would stay activated normally, and it would start pulling timing because timing is being pulled via translip. So even if you activated this, if you omitted this timer and you activated, if you omitted the translip timer and you activated it based on just these wickets alone and put an activation delay in it, it doesn't matter. That table is going to be activated because translip is going to be actually, I might have to revisit that. I might have to see if that works without it now. Maybe I just had some errors the first time. I wonder if it would work. But I don't remember the exact reason why. Maybe I'm just that rusty on it. But it has been a while. Yeah. I don't see why you couldn't do it without this. I mean, for whoever wants to try it out, they should try it out, see if it works. Mike, I don't think I understand what you're asking. Define it in HPT. Define shift RPM command. Yeah, HP tuners is you still have to tune the transmission still has to be tuned. You still have to tune the transmission in HP tuners, unfortunately. As far as the Holley's concerned, it has no idea what you're doing otherwise. There was one other thing that I did, which was downshift. See if I can get data log again. I don't know if I did a downshift in this. Yeah, I did. So there's a downshift right here. Where the heck is my TPS? Let me actually, I don't need half the stuff. I guess I didn't mention it earlier. I don't ever really use this laptop for tuning, but it's way better than my work laptop as far as the webcam, audio, power. It's not a chunky HP ProBook. Let's see, torque management. So here's torque management here. Jeez, these lines. You guys can't see any of this. So you can see this. I just realized this log file doesn't match the same revision that I had for like in the Terminator. So not everything matches up, but this is kind of a good idea just to kind of show what's going on. At least in this case, I pulled, it looks like I only pulled like 2.8 degrees of timing for the whole gear shift, but it gives you an idea. Probably have more stuff on my Let's see what do I have on my Holley. I'm doing the same thing right now with my 4L80. I made torque management work for the 4L80 too, but I had to generate trans slip. It works, but it's just oh, that's not going to work. I don't have V2 on this laptop. Like I said, I do timing based on trans slip percentage, which, let me see if I can get the OBS. There it is. See, I don't want data log. There we go. So at least in this case, I did, let's see, is that idle? Which one's this? Dwell. That was a boost builder. Okay, so for torque management, I just did it based on trans slip. You can make this number as high as 40% if you really wanted to, but I figured it just 25 to 0. It's always going to pick whatever's in that top cell if you're above this top cell. So if you're at, say, 500 pounds of fuel and you're at 40% slip, it's still going to pick negative 25. So I just always make my table a little bit smaller because it's more about tuning what's like on the, like, it's more about tuning between 0 and say like 15%. Like that's what makes it feel good. And when you deactivate torque management. So you can deactivate torque management by, say, being like, okay, below 5, just make this all 0, right? So it pulls out no timing when trans slip drops below 5%. I like to do mine, I like to leave this table kind of as is. And this table is actually kind of aggressive at timing pull. I should really be pulling, like, instead of 25 degrees, I should be pulling probably like 20 degrees initially, and then just immediately pulling probably around 15%, drop it down to like 5 or like -7 or so. I don't have my unfortunately my SD card got corrupted, the one that I used when I went drag racing, and I lost so much data logs from the 6L90. It's sickening, and that's my own fault. But what I do have, or what I can say, is smacking it in the mouth by taking like -20, putting -25 degrees into it, is pretty much a rev limiter. Like the thing just stops making power immediately. And you can start giving it timing not too long after that. What you can end up with is, so you have two slips that you're looking at. You have your actual torque converter slip, which everyone knows about their torque converter slip. It's not a constant at all. It's calculatable. You can calculate it based off of input shaft speed and RPM and determine your slip percentage there. But it acts like a rubber band, but it acts like a rubber band in both directions. Input shaft speed could be, say, 5,000 RPMs, and when you're accelerating, you could have an engine speed of 7,000 RPMs. But when you're decelerating, say input shaft speed is still 5,000, you could have a engine speed of 4,000 RPM. So when you think of it that way, that it acts like a rubber band, if you pull too much timing out too fast, because it acts like a rev limiter when it hits the motor, you could end up dropping the torque converter down below. You could drop you could drop engine RPM below input shaft speed. So you actually get a little bit of deceleration on the input shaft, and then when torque management turns off, because you no longer have slip, in other words, you're in your next gear, full power is given back to the engine, and then it has to travel through input shaft speed to get back up to slip. So you want it to pull enough power that it sits above input shaft speed. Like there's like a little bit of torque converter slip. Like if you could get it to do just say 2 or 3% of slip, that would be great, because it kind of acts like it's unloaded. Like it has like a little bit of load on it, but it's not complete, and it's not completely unloaded like how pulling so much timing off can do. And that also helps with drivetrain shock, because when you do go through that brief period of deceleration and then you come back into acceleration, you could end up damaging something. So in order to mitigate all that, start soft. This is actually really aggressive. I wouldn't recommend these numbers, but it has been a while since I've done it. Yes, exactly, with tight converters. Sorry, I can only go back and forth so many times. But Transadapt is done through HP tuners, although to be honest, don't update HP tuners. The new HP tuners is it stopped doing fast adapt for some reason. Don't know why. So you have to just drive it, and sometimes that really sucks. So whatever you do, don't update HP tuners. Yeah, and as far as tight converters, so my truck had, when I first put the 6L90 in it, I used a stock torque converter, and I threw 22, 23 pounds of boost through it. And I mean, it worked fine, but it was lazy because it was a very tight converter. And when I first started trying to get like this whole torque management thing to work, yeah, they took off fast adapt. When it had the tight converter and you would upshift, it would, like, you have to be very, I mean, obviously you're not getting a lot of slip because it's a very tight converter, which is awesome for like efficiency and whatnot. But the downside is it's kind of like, I look at torque converters and like the whole transmission, like, and how the whole philosophy of I guess like driveline harmonics and I don't know, I can't think of the name, like instantaneous torque, like how it hurts parts. Typically the parts in our transmissions, the 6L90 especially, is actually really strong, except for the 3/4 shaft. That's what I broke. But the parts, a lot of the hard parts are really strong, but what hurts them is shock, like shock loading. So a tight converter, it's great for efficiency. It's not good for spool, but it's great for efficiency. But it's really hard on the drivetrain, because when you shift, if you have no torque management, nothing to take some of the power out of the engine, it gets hurt. It gets really hurt. The first couple of times I drove the truck and I was driving it on like 12 to 14 pounds of boost, and it would upshift, I couldn't believe how hard it would hit, especially when I had shift timing around like 0.1, 0.15 seconds, which again, I still don't recommend. That's too fast. But what I do now is I have a 20, it's like a 2400 stall converter. It legitimately took 1 second off my quarter mile time. I went from a 12.0 when I first went to the track to an 11.02 with just a slightly less tight torque converter change. And I would drop my 60 foot from like a 2.2 to a 1.7. But I worked on the torque management for the shifts, and I had two things going. So I had my gear permissive table also deactivate my boost controller. So whenever boost control, or whenever my upshift would happen, while those new clutches are coming on, I'm retarding a lot of the timing. Retarding timing creates a boost spike, and creating a boost spike means now I have tons of boost sitting in my intake, and as soon as I give myself all that timing back, I could potentially hurt the bottom end, especially with a tight converter, because you're dropping RPM
significantly on, like, say the 1.2, you're dropping 40% RPM, which I'm going to do some quick math here. 0.60, just do 0.6. Yeah, so you're at 7,000 RPM and you shift and you drop down to 4,200 RPM, you might be afraid of folding some rods. So there's a couple things you can do. One of them is torque management, and then the other thing is you could do a time-based, time and load-based ignition retard or a spark retard. So whenever gear permissive, which we'll go back to that. So essentially, whenever this table turns off, whenever your torque management table turns off, you can base it off fuel flow and say time. It'll pull some timing and ramp it back in. So that way, when it's done with the gear change, you can walk your power back in as opposed to just here's all the spark back. So with tight converter setups, that could be very beneficial. Or as some people might do, they that was the thing. I did hurt the engine on the stock converter. I bent I think 2 rods, just barely bent them just on an upshift. No huge power addition at all, just an upshift. So let's see. Yeah, the input shaft is, I mean, it's really strong. The 3.4 is what I've heard is notorious with big horsepower guys to break. And I was no different. I wasn't even at the track when I broke my 3.4. My transmission just straight up, when I went to the track, it refused to shift into 4th gear for whatever reason. I'm sure it has some hydraulic issues on the inside. There's some stuff that, they're a pretty good transmission if you take care of them. But I had mine broke on a burnout, just around town. Not even like a crazy one either. It just upshifted way too hard and just snapped it. And then instantly, no more 4th gear. Had to put it in D3 and drive it back. Drove it on the highway a few times. Yeah, sitting around at 4,000 RPMs at 70 miles an hour. So if anyone has any questions, feel free to ask. The 4, 5, 6 clutch packs are also the smallest of the clutch packs. In 5th and 6th gear, occasionally I would get a little bit of slip. Wasn't enough to throw like a transmission check engine light or anything like that. Or I guess check transmission light. Nothing ever showed up in HP tuners, but every now and then you'd see it. So if anyone has any questions, feel free to ask. Just going to give it a couple more minutes. And if that's it, then I'll just end the stream. I plan on building. I don't know how deep I'm going to go into building mine. I might just do the billet 3.4, but that's pretty pricey. Might just try my luck again at another stock 3.4. They're pretty cheap, around like $100 or so on eBay. And then figure out what's going on in my hydraulics, because I think I'm having some apply issues to my 4, 5, 6 clutch pack and my 3.5. I think my 3.5 is having some apply issues too. Both of them have hydraulic leaks. I mean, like, they have notorious hydraulic leaks. So All right, guys. Well, I'll let you all go. All right. Hope this helps. If you guys end up with any more questions, either ask them on Facebook or the comments here. You can reach out to me on Instagram. It's also scrapmetal_sleepers. But other than that, all right, guys, take it easy.